that'll do it.
Yeah, it'll do it.
Okay.
Okay.
Start the slideshow back up.
Slideshow here.
If you go back to just from the beginning of that, from the current slide, I'll just go ahead. The mouse is not so good.
Yeah, the mouse is. There we go.
Okay, there we go. All right. So I've been very happy with Greenfoot, and we'll see it today. Also, I'll go to a demonstration very, very quickly. I mean, I'm going to talk a little bit more about the introductory environments. I've heard some of you mention Alice and Scratch, and there are others, and they're a nice sort of syntaxless programming to environments that are becoming pervasive in introducing programming. And then in the high school curriculum, and I know when I was at the university curriculum, we go from that and make a big jump right to Java. And it's a very, very large jump. And Greenfoot, from my perspective, is a fantastic bridge from the introductory environments from Scratch and Alice to full-fledged Java. And my experience this year is that it's really a fantastic tool. And part of the reason why it's a fantastic tool is that in the same way that you can use Scratch and Alice to attract non-traditional communities to programming, you can use Greenfoot to attract non-traditional communities to programming because you can focus on simulations, you can focus on games, you can do sort of problem solving in a programming class from the very, very beginning. Students love to use it, and I have some quotes at the end of the student quotes and parent quotes of people's experiences. And what's good for me as a high school teacher, I don't have the time that I had when I was in the university to develop curriculum. I mean, my day is really full, like shockingly full. And there's an incredibly active teacher community that has resources, that have projects, have exams, have curriculum ideas. It's a very, very active group of people who are sharing resources right now in Greenfoot. So you're not alone. Once you get signed up as a teacher, get access to what they call Green Room, their teacher forum. You have access to this. That helps a lot. So it starts at greenfoot.org. Oh, well, actually, let me back up a slide. I didn't point this out. So here at this link, if you're following along, I put both. It's actually not the current version of the slide. It's the version before what I did this morning. Oh, sorry, not the current version of the slide. It's the version what I did this morning, and a Greenfoot scenario that we can play with as we go. So there's resources there. Everybody who wants it have it. Yes. All right. Good. We're working. All right. So I think I found the right place to sit. Okay, so I went out to the Greenfoot Gallery, something else that we'll talk about, and I've got some Greenfoot scenarios. I just show you the kinds of things that are done. So here's the Greenfoot world, and Greenfoot is both a place to run animations. It's also an IDE. It was developed by La Trobe University in Australia and Kent University in England. It's the same people who brought you BlueJ. I mean, I heard you mention BlueJ. It's the same people. And when I used BlueJ one semester long ago and didn't really like it, and I'm amazed at how much I love this. And so this is their tutorial scenario. And it's wombats and leaves, and you have a wombat that wanders around the world looking for leaves. I'll just show you sort of the way it works. If I right mouse click on the wombat and say new wombat, there's a wombat, and the wombat exists in the world. And then once the wombat's there, I can ask it to do things like I can ask it to act, to do something, and it doesn't do very much. It runs around, and if I run the scenario, you'll see the wombat running around the walls. What does that look like to you?
Carol the Robot.
Yeah, a lot of Carol the Robot flavor in this, exactly. However, it's more robust than Carol the Robot. I mean, it's a nice addition, and because you can do things with it in this, like create breakout, do you know this is a scenario written by Barb Erickson at Georgia Tech. I don't know if you know her. She and her husband Mark Gusdile have been doing a lot in introductory programming education, and so this is a student project. Everybody loves Breakout, right? And very early on, it's the same architecture. It's you have a world that has actors in it, and then there's a sense, act, react loop that runs over and over again, and the actors in the world decide what to do. And so so the ball decides to move till it hits something, or a brick does nothing until a ball hits it, and then the brick removes itself from the world, and that's basically Breakout. So that's pretty cool, and then people get kind of crazy with it. Like I love this one. This is one. This is fabulous. Let's see if I can get them to run. Waterworks. This is the problem with this game. I could probably spend the rest of the time just playing this game. It's really cool. It's really cool. So my mouse is not so good. Yeah, it's good. Fight to get to the run button. There we go. All right. So what you see is they sort of have this water dropping, and the idea is you get to move to you take this little wall and you move it here, and then the water bounces off of it, and then you angle it, so you try and get, the idea is you want to fill the bucket, and you finish a level when you fill the bucket. All right, so I'm not going to do it once. Okay, let's see. There we go. Oh, I'm missing now. Almost got it. All right. Oh, come on, Robert. All right. I could do this so well when I was practicing. You got to see one level finish, right? Oh, there we go. Now I got a mouse. Yay! All right, there you go. And now this one's a little harder because I've got to bounce it through the opening there, and I won't spend the whole time, but I did. When I first saw this game, I thought, wow, that's really cool, and I played it for a long time, and that's kind of the appeal. I mean, what was really nice at the beginning of my programming class was my students couldn't stop programming. I mean, seriously, they couldn't stop. It was great. I had parents complaining to me, my son is only working on your class and nothing else. And I'm thinking, great. It's really, really nice. Okay, so back to the presentation. Okay, back to where is it? Oh, there it is. Okay. Well, from Zoom slideshow. Okay. So it's fun, and you can kind of see it. And so it's not just Carol the Robot. It looks like Carol the Robot, and really, underlying it, it's the same thing. But it allows for incredible creativity, and still inside the structure of early programming. That's the exciting part. All right. So name a goal of your programming class. What's a goal? Like here's how I put it. Students who successfully complete my course will. How would you finish that sentence? Yeah.
Learn how to break a task up into methods.
Okay. What else?
Be able to solve the problem.
Yeah. What else?
Apply repetition and decision structure and solving problems.
Okay.
Debugging skills.
Debugging skills. Okay. What else?
Have fun.
Good. What else? All right. Well, so I made my list. Your list is fantastic. So this is my list for my AP Java course. So I said students who will successfully complete my course will they should know the Java language, okay? And I'm using the AP definition of the Java language, which is the language itself plus a little bit of Java.util, and a little bit of Java.io, but basically the Java language. What I'm going to write small and medium-sized programs, and I'm not going to define what small and medium-sized means, but I want them to at least be able to do some, be able to write something that accomplishes, something meaningful. What did I do? Cited. Oh, medium-sized. Okay, all right. Typo number 1. Develop a love of programming. Many of them have a love of programming coming in, but I'd like them really to feel like this is a worthwhile task. I want them to feel that they were challenged when it's all over. Okay, and be prepared for later courses, whatever they are. And then from the high schools, one problem in high schools is that there isn't a follow-on course. Many underclassmen take AP Computer Science, or many of the students taking AP Computer Science are underclassmen, and I don't know what to do with them the next year. And then finally, be prepared for the AP exam. And so, you know, so these are ones I came up with, and what's happened is that we have a 2-course curriculum, and the first course is Introduction to Programming, and then the second course is AP Computer Science. So in 2 years they go from no computer education to taking the AP exam, and I have to get them there. So we use Scratch at the high school, and Scratch looks a lot like what we just saw. Have you used Scratch? Do you know Scratch? No. Oh, a lot of people are saying no. Well, maybe before we're done, we'll download Scratch and install that here too. I mean, Scratch is exciting. Yes, sir.
Excuse me, my education, but this is a California question, but is your AP exam the California AP high school?
AP is run by the College Board. It's a national program, and the idea is they work in conjunction with colleges to have a curriculum that should somehow overlap the first year computer science, or for AP Computer Science, the first year computer science. It's basically the equivalent of Java 1 and Java 2. It's a highly programming oriented. If you look at the exam consists of kind of what does this code do kinds of questions, and the multiple choice questions, followed by some open response that asks them to write some code. And it's a computerless computer exam. It is what it is. Yes, sir.
Some of those are familiar with LS or Scratch or whatever, and they have this sort of environment going. So how does the transition go to Joe?
Okay, so I don't want to take the time, but I feel the need to show you Alice and Scratch maybe what they are, but I'll try and describe it. Okay. What they've done with Alice and Scratch is they've taken learning the syntax out of the equation. They have, like, if you want to do a for loop, you have a for loop block, and then you drag in the statements you want to go inside the for loop. And so it's clicking together blocks. I think Lego Mindstorms does something similar. I mean, it's programming by drag and drop. And so the intention of those environments is that the students can solve problems in a way that they can just focus on the algorithm without having to focus on the syntax. Okay. And it's quite successful. There was a study that the Scratch people did. I thought it was great, where they had kids in these computer clubs around the country without a teacher walk in, and pretty much they're successful at teaching themselves Scratch without any intervention at all from an adult. It works well. What I found, what I did this year with Greenfoot is there's a textbook that goes with Greenfoot, and the textbook is really a problem-oriented textbook. It doesn't teach. Here's a for loop. Now we have a for loop. What it does is it walks through scenarios. It uses very object-oriented language. It walks through scenarios, and in the beginning, what it does is it says here's code that causes the lobster to run around. Now make the crab run around. Kinds of things. So it's programming by example early on, and the students have no problem doing it. I never once said you have to terminate a Java statement with a semicolon. Those words never left my lips, and yet every student knew almost from the first day that you had to terminate statements with semicolons because they saw the examples. They were using loops before I ever said the word loop. It was because they had examples in the code. If we look at, let's go back to Greenfoot for 1 second. Let's pick any one of these, but let's pick the Wombat one because it's simplest. If you click on one of these, and these really are classes, and this really is a class hierarchy. I clicked on the actor, and the actor is one of their classes. Okay, let me come back. Oh, that's still running. There's breakout. Oh, there's the Wombats. Okay. So if I click on the Wombat, it opens up the code. I'm now in an editor. And so you'll say, so when the wombat is constructed, I have a mouse. When the wombat is constructed, hold on, there we go. It hasn't eaten any leaves, and so it has this found if it finds a leaf, eat the leaf. If it can move, else turn left. So in other words, if it hits a wall, it turns left. It can't move anymore. And so the code's all here. And let's say, So here's moving. So this code's already provided. So they have a model, and we give them very specific tasks based on the model, and that's the early phase. So that was sort of a long answer to your question, but what I found was I didn't have to do much of anything early on. I just said, here are the chapters from the book, start working through the scenario, and they developed a game. Okay, and then later on things got more complicated. And what I haven't done with them is now that I've been teaching Java to them for 6 months, I'm going to go back to it and see if they can actually build something more complex now. But early on, what I liked about it was they were learning syntax, they were experiencing loops and conditionals without ever really knowing what they were doing, but they were succeeding at it. And so when I later on more formally presented things, they're like, yeah, we know how to do that. Yeah, we know what it is, and we're just able to talk about nuance as opposed to introducing things from the beginning. So it worked. It worked quite well. Okay. Slideshow. There we go. Okay. So one thing that I'm quite concerned about, and I've been concerned about for a while, is diversifying the programming classroom in terms of the students, or diversifying the students. And other people have spent a lot of time thinking about this. I'm particularly interested in the work by Caitlin Kelleher, who was Randy Pausch's graduate student in the ALICE project, and the stuff at Georgia Tech with Mark Guzdow and Barbara Erickson. And actually, Wellesley High School is in Wellesley, Mass, where Wellesley College is, which is a women's college, and I've been working with their computer science department. And what all of these people have found is that, for instance, if you want to bring women to computing, it can't just be writing games. There are other avenues to bring other people into computing. And Caitlin Kelleher has made a strong study in ALICE, working with middle school girls, where what she did was, rather than having the girls build games, she had them tell stories. And in fact, if you go to the ALICE website, you'll see there's a version of ALICE called Storytelling ALICE. That was exactly aimed at, that was developed by Caitlin Kelleher exactly for this purpose. And so I'm not saying that there aren't girls who want to develop games and that there aren't boys who enjoy storytelling, but to expand the reach of programming, I want to be able to offer both. And what was nice about Greenfoot was Greenfoot offered both. Greenfoot allowed me to do the same kinds of things that I did with ALICE, that I could do with Scratch, that I could offer really a wide range of problems for the kids to solve. And along the way, still emphasize the computational thinking, still emphasize the algorithmic thinking. So all that's really good. The challenges for all these things is that it's not full programming. It's not C++, it's not Java, it's not full programming. And I put this last bullet on, does it matter? And you're saying no, maybe it doesn't matter. And I'm thinking more and more that it really doesn't matter. For instance, are you familiar with App Inventor from Google? Some people are saying yes, some people aren't. So Google Labs they took the block structure of Scratch, they took the exact code from Scratch, and they made a nice environment for developing cell phone applications on Android phones. So it's drag and drop programming for Android development. And it's marvelous. Yeah? And so I have an after-school group now who are doing cell phone development without having to be programmers at all. And another thing that I read just this week, it was on ACM Tech News, I read this week, that the Scratch people now are looking at block programming for building for controlling your house, for having integrated house, for having the washing machine talk to the dryer, or, whatever it is you want to do. So it's real programming, but with the the Scratch interface. It's really cool stuff. So does it matter? I mean, is block programming the future of programming? Who knows? Okay. So here's my slide of Greenfoot for the bridge. In the intro course and the CS0 course, we start with Scratch, with Alice, with App Inventor, with media computation and Python. We start with something that's a simpler environment. For some reason that I can't tell you, we want to turn these people into Java programmers. And maybe because Java is, from your perspective, maybe your students can get jobs in Java. From my perspective, Java is the language of the AP course, so I have to teach Java. So I have to go from this incredibly appealing world of introduction to programming, which is nice to say it's incredibly appealing, and get them to this detailed, nuanced world of Java programming. And I'm using Greenfoot as the bridge. What makes it the bridge, and this is I've covered most of these things, is that it has all the flavors of the intro stuff, and yet it's in Java. So students really begin to learn. There are resources, and if you go to that web page that I had up there, I had on the, let's see, here it is. No, that's not the web page, but it is here. So if you go to the web page, I've put links to the many resources out here. So all the things I've talked about today, I put links to on this website. You have access to that. What's really nice well, actually, let's go to the gallery first. So if you go to the gallery, what they've done is they've made a YouTube kind of interface for Greenfoot projects. So if a kid develops something they think is really cool, they can put it out to the world, and the Greenfoot people both have a showcase of things they like. They have the most popular scenarios, so if you really are drawn to this, you can try and get these things, get your scenario into the most popular. And what's kind of nice too is that you can run them on that they've built the environment so you also can run them as applets. So here's I don't know what invisible Pong is. So hopefully it's more than, there we go. Press 1 for single player, 2 for multiplayer. Well, I'm all by myself. Oh, I got to run it first. I hit the run button. Okay, press 1. There we go. Oh, so what's happening here? How do I control this? What do I do? Oh, there we go. I'm over here. Okay. Oh, look at that. So what's invisible about that? I'm sure it's oh, I see. It's going to be. All right. No. Oh, I can go forward and back too. Oh, cool. Okay. So that's really fun, and it's online. So I read a scenario. I can show my friends. I can upload it. I can say, hey, play my game. Hey there. Catch my water drops. It's all great. All right.
Would this be able to, if you show this to your students, you could also then improve your class sizes and more programming classes?
I hope so. Hope that works.
Because that's what I need at my time.
Well, notice also what's good. You can download the source code. So that if I want to see how's invisible Pong done, I can reverse engineer it. I can download the source code and figure out what makes it tick. So yeah, I hope that's the case. Last year they ran a contest, and they ran a contest for adults and kids, and the contest was use Greenfoot to write to do something about environmentalism. So it was focusing on the green in Greenfoot, the Greenfoot code point competition, and that got a lot of kids interested. They also had a competition called Greeps, which was a challenge. Much like, actually, let me show you the code that if you want to actually write a little Greenfoot code yourself. Here's a world that I put on the website. We'll dig into the code a little bit right now. What time am I done?
You've got 15 minutes.
I got 15 minutes. Perfect. Okay. All right. So on that web page, you'll see there's a Greenfoot scenario that's zipped up if you're following along. But let's just do it right now. Here, so that's an ant. Okay. That's an ant, and the ant when it runs around, it's running around, and what we're not seeing. Okay, it just hit the wall, and ants are very fragile. I know that's not true in real life, but ants are really fragile. If they bump into anything except for sugar, they die. All right, so the ant hit the wall, and it died. I'm like, okay, so that's the first challenge. So this is one of the homework assignments that I gave to my students. Except I have more code here than I gave my students. All right, so there's one ant. I'm trying to open the editor, and hopefully I'll be able to open the editor. Let's try this again. Hopefully I'll be able to open the editor. Okay. I'm just trying to double click, and there's something that's keeping me from. I'm just trying to double click on the. Let's see. Right click. Okay. Open editor. All right. That did it. Well, except maybe, unless it's open. There it is. I bet that's it. It's already open. That's the problem. Yeah, I've never used Windows 7. This is my first. Okay, so I don't tell them why. So that's what I give them. I don't tell them why it's not running into the walls, but really what this is a project on force vectors. So really what's going on is that the ant is reacting to forces. And if you notice, I have a force that's inverse to the distance from the top wall and inverse from the distance from the right wall, but I haven't included the bottom wall and the left wall. So eventually, any ant that I put into the world is going to die by crashing into the left wall and the right wall. So I wouldn't give the students this code, but I'm just going to uncomment. Because I don't want to figure any problem out. I'm just going to uncomment it. Well, and there we go. Okay, so uncommented, it's changed. Okay, so I'll recompile everything. You'll see that the lines in the classes mean they need to be recompiled. There's the ant in the world. And now the ant's going to run around the world. When it gets towards the wall, it's going to go, there's a wall there, and it's going to not hit the wall. And so that's pretty cool. Well, let's put another ant in the world. So I'll right mouse click, new my ant, let's put another ant in the world. And there's another ant in the world, and they just miss each other. If ants crash into each other, they also have a problem. Okay, put a third ant in the world. Eventually, what will happen is the ants will crash into each other. Almost. And I can force the issue. What I can do is I can go into my empty world, go to that code, which I'm sure is down here. Now they know where to look. Okay, empty world. Not the empty world. Simple world. Go to the simple world. And in my simple world, change the number of ants from 1 to, let's make it 100. Okay, right. So, right. Well, this is sadly what happens in the house sometimes in the summer. When ants start crashing into each other, and up here, this little tally, this tabby that's saying, there's only 39 ants left. Oh, it's chaos, I tell you. Exactly. All right. So the ants are having trouble, and so what we need to do is take into account. Each ant has to know about the other ants so that they don't bump into each other. All right. So I'll go back to my ant.
It looks like they're walking through dead ants.
Yeah, they are. The dead ants don't bother them. They just walk right over the dead ant. Okay. So I'll go back to my ant. And we'll do the same thing we do for walls, and actually I already have the code written, so I'd say just have a factor of say, okay, we really each ant's going to factor into the final force vector of the way the ant's going to behave for the factor of 1.2, and so you'll see that I have this avoid ants method. Where is avoid? I know this is something the students had to write. Where what it did was it got all the ants within a certain radius, and then what it creates a resultant vector by subtracting the direction of that ant. So it's moving away from the other ants. Okay, and then I have the weighting factor at the top. This is how much do I weight that vector. And so if I go back to Greenfoot, okay, and spiders, recompile, and now the ants know about each other. And so if I run it, this is kind of fun to watch. I think that's so cool. Another thing I could stare at all day. The ants when they recognize it, the ants, and look at that, is we've gone. And so what's happening here is these rounds. This is counting the number of act cycles. And so so far we've gone over 1,000 act cycles without a casualty. Okay, so it took me a long time to figure out what the right values were to make that work. But that's the idea. Yeah, exactly. Exactly.
Because you're expecting to do, how much help do you give them in teaching what vector is?
Oh, almost none. Almost none.
Turn them loose.
Turn them loose, yeah. Let them figure it out. Let them do
it. It's a really process. I think there's freedom right in the center.
Yep, let's talk about that. See, this is a good kind of question. So this is a Java class hierarchy. So for instance, if I double click on world, I don't go to source code. Well, actually, I first got to pause it. If I double click on world, I don't go to source code. What I go to is the Java API definition. If you're a Java programmer, you live and breathe with this stuff. This is the Java doc results. So this is telling me everything that a world can do. They're the world methods, and so this is services I have available to me as a programmer writing a subclass of world. Okay, so I think that's the answer. Spiders, yeah. So I have that, and then so these are different worlds, and in the end, the real game comes when you get to this world. Yeah, exactly. Okay, so we come to the world of spiders and create a new world of spiders. Now we have the same kind of world where we have spiders and ants. So I'm going to use this as an example of the programming process. So what I did was I gave them a code that showed the way that the ants repel from the walls, and I gave them most of the code for the way that the ants repel from each other. Okay, I gave them that much, and then I gave them nothing else. And then the goal of this game is you want the ants to eat all of the sugar. So they have to, and when an ant is standing on top of sugar, it eats sugar. So we want the ants to eat all of the sugar, and at the same time avoiding each other and avoiding the spiders. That's the goal. And so they have to say they take the method that the way the ants avoid each other, and can use that to avoid the spider. And then they figure out very quickly that if you subtract to avoid, if you make it an add, you get attracted to the sugar. Right? And so they take the model of a method and they write other methods. And so it's not real programming, but they're learning syntax, they're learning loops, they're learning conditionals, and they're getting ready to actually learn Java in classes, right? And then the other thing you see is right away they get class hierarchies. Inheritance is often really difficult to teach, but they see, well, what does my ant do? Well, let's see what an ant does. And then click on ant and see what an ant does, wherever that's coming up. And then what's an actor? Let's see what an actor does. And they get this idea of inheritance right away. Yeah.
I want to get you off track here.
That's okay.
But, do you have an example of what you were talking about earlier about something like this and telling a story like with a girl?
Okay, hold on. So, what I suggest, actually, you can find that for yourself. What I suggest you do is go to greenfootgallery.org, and you'll see a huge collection of already built scenarios, and a lot of them are games, but many of them aren't. These science simulations are really cool. I mean, there's a whole bunch of things that are out there, and some of them are stories. So have a look. So what I want to do now, and do I have 5 minutes?
Good. 7 or 8.
7 or 8 minutes. Okay.
We run an hour.
Yeah. Right. So okay. Well, I don't know. When I ran this at home, it seemed to work. But when I ran it here on my computer yesterday, it wasn't so successful in beating the ant. So as I put in comments the values here. All right. Let's see. There's 12 and 5. Okay. So these are the weights. So it really wants to avoid walls. The ant factor is 1.2. This is the attraction factor of sugar. Sugar is attracted by 12. The spider factor is 5. And then these are the radiuses where we care. Okay, 50, 150. And let's see what happens with the... Yeah, exactly. The unit of distance is pixels. Okay, so recompile. Oh, so the spider is faster than the ants. So the spider, if a spider latches onto an ant, it'll catch the ant. What happens is, though, the spider is running with another model, and the spider has a very short attention span. It'll start chasing one ant, and another ant will go, oh, another ant. And so as long as the ants are smart about it, they can keep away from the spider. Okay, see what? There you go. So sorry, see there's a spider eating, there's an ant eating spider, and an ant eating sugar. Sorry, these are eating sugar. Okay, and the spider's chasing around. We still have 10 ants, 10 out of 10. Okay, and so the goal here is to both eat all the sugar and do it in the competitive part here is can you do it in the smallest number of rounds? Okay, so we'll see. This pile of sugar is almost gone.
So you heard it seems to make this as efficient as possible.
That's right, exactly. Yeah. Looks like this is going to be a winner. I'm feeling optimistic. Okay, we have 2 sugar piles gone. The sugar pile's about to go. So notice the sugar pile shrinks. So what happens is every time there's an ant there's a counter, and once the counter gets to a certain level, the size of the pile gets smaller. It changes its image file, and then it keeps going and gets smaller. Okay, we're close now. See?
Spiders and ants the same speed?
No, the spider's faster. Yeah, by a factor of I think 1.5, 1.4, something like that. I have to go look at the code.
How about the detection? So the ant detects a wider radius than the spider?
So I don't remember the spider code. I spent much more time working on the ant code because that's what I had the kids do, is work on the ant code. So it's just as I said, I didn't write this. Is it all over? It's all over. So 1 in 5,000 rounds. Okay. All right. So that was a win. So it is possible. It is possible. And so this was in the first 6 weeks of the Java class, maybe even the first month. I had them do they started with a series of 4 or 5 of Greenfoot projects. This was the last of the Greenfoot projects that we did, and every student got to the point that to this point pretty much. Yeah, nobody came up with a real spectacular behaving one, but this is pretty good. I mean, this one is pretty good. Now, I didn't write the scenario. This was a project I got from Green Room. But I really liked it, and so here's an example of one, a completely different one. This is from the book. There's a piano, and so you can write it. So you write the keys, and when you click, it plays music, so the kids build a virtual piano that when they use the mouse keys, the key on the screen goes down and you hear music. That's a really fun project. The kids really like the music making project. Okay, I have 2 minutes. I just want to show you a few quotes and answer any questions. Well, of course, you can do 2 minutes. All right. So, okay. So here are comments from parents. I mentioned this one to you before. This one I love. This was at parent conferences in September. I'm a bit worried because my child is spending all his time in your course. You know, I was just like, wow, that's great. Thank you. All right. This I like too. This is from a kid who's doing well in only one subject, and my child is proud of the work he's done. This is the chair. Well, I guess I can't identify who the person is. So but the child of a well-known computer scientist came up to me and said, "We had no idea she had any talent for programming." That was good. And the student comments. Actually, as I walked out the door yesterday, I said, "Hey, I'm going to be talking about Greenfoot at a conference. What should I say?" And they said, "Oh, Greenfoot, the good old days." You know, it's like they really like it. Okay, that's my presentation.
You go back to your slide with your URL for it.
Oh,
I clicked on it and it didn't work. I think
okay, sure. I did that quickly. There we go. Yeah. So and I'll put more resources up. No, it's just tinyurl.com, and then it's really a Google site that it takes you to. Yes, sir.
Do you do much with having students create scenarios from scratch?
That's what I want to do next. Now that we've been programming for 6 months, what I'm thinking of doing is saying, now write your own, write your own, and that's where I was hoping that the Greenfoot people are going to have their code point competition this year because that was good. They had a theme and they gave T-shirts and other things. But so what I may do is in my class have a theme. Say we'll take something that's related to the community and you have to write a program, somehow associates that and leave some creativity for it. I think they'll be able to do it now. But that's the next step. That's the advanced step. Yes.
I'm curious about the structure of the Greenfoot itself. Do you have a game loop?
That's all it is. It's a very, very simple game loop. Every actor has an act method, and what it does is it just iterates through all of the actors in the world and calls the act method. Okay, that's all it does. Anything else? Thank you all. Thank you. Oh, yes, my name is. Yes.